Hi, we are from BTPD 32 and we are going to present our business mathematics presentation. So for introduction, I, Ifa, will present it. In business mathematics, the application of linear and quadratic equation will often ask about supply, demand and market equilibrium, revenue function, cost function and profit function, break-even point and optimization in algebra or calculus. So the goal of this application is to find the market equilibrium for price and quantity in demand and supply. This will show how markets are often affected by the changes that affect price and quantities. The market that is unaffected by any failures or government intervention will have the tendency to move the price and quantities toward the equilibrium benchmark. Next, the revenue function represents the total income from selling its product, and it is usually dependent on the number of units sold. The application in the cost function is where it shows what is the total cost incurred for producing a given number of units. This will include both fixed and variable costs. The profit function is essentially in any business calculus as the profit function show how much profit a company made. Break-even point in corporate accounting is where the company operations start to earn a profit. The break-even point is the production level where the total revenue is equal to the total cost. The last one is optimization. This is the process of finding the minimum and maximum value. The maximizing is usually used by the profit and revenue, while minimizing is the cost. I will pass to my friend for the part 1.
Okay, for part 1, question number 1, a product's demand and supply are represented by the QD equals to 100 minus 2P and QS equals to 20 plus 3P, where P is the price and Q is the quantity. For the first question, find the price at which demand equals supply. For the second question is illustrate the demand and supply function on a graph. For the first question, we're going to use this formula QD equals to QS. So put in the equation inside the formula and then we do this and then we get P as 16. And then we use any of the equation and then put the 16 inside this equation and then you get Q as 68. For the graph, this is the example of the graph. For the second question, if a subsidy causes the supply equation to change to QS equals to 30 plus 3P, determine the new equilibrium, price and quantity. So using the same formula, QD equals to QS, you put the new equation in here and then you get P as 14. Same as the first question, you put the P in the new equation to find Q, which is 72. Okay, this is part 2.
Okay, we move on to the part 2. So, as we can read from the question, so we be given two questions. So, for question 3, the question asks us to find the price at which demand equals supply and also to illustrate the demand and supply function on a graph. Question 4, if a subsidy causes the supply equation to change to QS equals 30 plus 30P, determine the new equilibrium price and quantity. So for the first equation, as we can see, for the revenue function, we be given the 80x. So for cost function, be given 50x plus 500. So as we all know, revenue function equals to cost function. So we put the given equation there, and then we need to change the 50x to the left hand side. 80x minus 50x will be total to 30x equal to 500. So for 30 we bring to the right hand side. 500 over 30 will be the final answer is 16 plus 6, 16 plus 6, 7. So this is the graph. And so for question 4, revenue function given is uh, negative 2x square plus 80x. So as we all know, the x square might be a and the x is b. So we put it in the equation that negative b divide 2a. So x equals to negative 80 divide 2. In the bracket we put negative 2. So the answer will for x is 20. So we put r 20 equals to negative 2 in bracket 20 to the power of 2 plus 80 in the bracket 20. So the final answer will be 800. So this is the graph. So this will be the graph. So we move on to the next presenter.
So the part 3, I will discuss about question 5, which is market equilibrium analysis. So the question is, for a different product, the demand and supply function are given as QD equal 120 minus 4P and QS is 40 plus 2P. So what we need to do is we need to calculate the equilibrium, price and quantity, and discuss how shift in demand or supply could affect the equilibrium. So first we need to calculate the equilibrium, price and quantity. So first we need to put a formula which is QD equal QS. So QD is quantity demand and QS is quantity supply. So we need to put the equation in the formula. So 120 minus 4P equal 40 plus 2P. So first we need to do 120 minus 40, so we get 80, and 4P plus 2P we can get 6P. So the answer for A is 80 and 6. So it's not finished yet, we need to find a price, which is we need to divide. So 80 divided 6 is 13.33. So the price is 13.33. So for the next is discuss how shift in demand and supply could affect the equilibrium. So for a demand, a change in demand happens when a factor other than the product price like income change. For example, if income rise, people can buy more, shifting the demand curve right. If income falls, people buy less, shifting the curve left. And next for the supply, a change in supply happens when a change in supply happens when factor other the product price like production cost change, lower cost increase supply, shifting the supply curve right, where high cost reduce supply shifting in left. So next is question 6. So for the question 6, break-even analysis. The question is, a startup company incurred a fixed cost of Rm 10,000 and a variable cost of Rm 20 per unit. It sells the product for Rm 50 per unit. Determine the break-even point, and we need to discuss the significant And next, we need to discuss the significance of the break-even analysis for business discussion making. So first, we need to determine the break-even point. So first, we need to find the revenue. Revenue is Rx equal XPX. So we need to put all the equation inside the formula, which is x50, and the answer is 50x. So for the cost is CX, which is fixed cost, fixed cost is 10,000 plus 20x, and profit Px equal Rx minus Cx, which is 50x minus 10,000x plus 20x. So we need to do a 10,000x plus 20x first. So we can, okay, for the question 6, so we need to, so how to find a cost with Cx equal 10,000 plus 2x. Profit Px equal Rx minus Cx. So we need to put the equation in a formula. So 50x minus 10,000x plus 20x, and we can get 30x equal 10,000x. So 10,000x we need to divide by 30x, and we can get the answer 3,333.33. So the next question is, so how break-even analysis can affect the business discussion making? So the break-even point is when total revenue equal total cost, meaning no profit or loss. Business used to break-even analysis to find out how many units they need to sell or income they need to cover costs. Beyond this point, sales generate profit and help investors see when they need to start earning the return. So I will pass the next presenter.
Okay, so next is the part 4, question number 7. So the question is a manufacturer profit function is Px equal to minus, so negative 5x square plus 150x minus 500, where x represent the number of units sold. So first question, we have to determine the number of units that maximize the profit. So as you can see, for number 1 question, it is already given the profit function, that is Px equal to negative 5x squared plus 150x minus 500. That is the profit function. So this is the quadratic function that opens downwards because the coefficient of square is of square is negative. Therefore, it has a maximum point. So first we have to determine the number. We have with the x coordinate of the vertex of the parabola. So for this question number 1, we have to use the vertex formula. There is x equal to negative b divided by 2a. So you just substitute the a, b, c in the quadratic function. So we substitute, will be equal to x equal to negative 150 divided by 2 times negative 5. So you will get, if you count the calculator, you will get 15. So the number of units that maximize the profit is 15 units. Okay. So next, this is the question for number 2. Number 2 need for calculate the maximum profit. So how we want to calculate this one? First, you have to substitute the value of x in Px. So see, you already have the x equal to 15. So we just put into the profit function Px. So we be P15 equal to negative 5 times 15 square plus 150 times 15 minus 500. So if you just calculate with with your calculator, it will be simplified into P15 equal to negative 1125 plus 2250 minus 500, and the last answer you will get is 625. So the maximum profit is $625. Make sure you refer the currency through the question. Okay, so we already have these two. So next, the last question, we have to find the graph. But before we plot in the graph, we have to find first, we have to find the vertex. And the vertex, we already have the x equal to, x is 15, y is 625. So we have to, next step, we have to find the y-intercept and also x-intercept. So for y-intercept, you just have to set x equal to 0. So by using quadratic function px, you just substitute 0 in every x that you have in this. So it will be equal to p0 equal to negative 5 times 0 square plus 150 times 0 minus 500, and then you will get the answer is negative 500. And then next, um, for the intercept, x-intercept, we have to occur where the profit ps equal to 0. So this means the solving the equation will be ps equal to negative, so minus 5x squared plus 150x minus 500 equal to 0. Okay, and then I want to simplify the equation. So to simplify the equation, you will get, I will simplify all the numbers in divided by negative 5, because since negative 5 is a common factor for this equation. So you will get x squared, you will get x squared minus 30x plus 100 equal to 0. So this is the last, as you can see the below, it is the simplified equation that we're going to use to find the x. So how to find the x? We have to use the quadratic formula. Okay, this is the solving by quadratic formula. You already know this. Make sure you memorizing the formula. Okay, so you guys just have to substitute a, b, and c in the formula. So you will get x equal to negative in the bracket negative 30 plus minus square root negative 30 square minus 4 times 1 times 100 divided by 2 1. So you just calculate it one by one. Make sure you calculate one by one using calculator, because we don't want you to misinterpret the answer. So you just divide it one by one, and then you will get two answer because they have plus minus. So first will be 30 plus 22.36 divided by 2, and then you will get 26.2, and the next answer will be 30 minus 22.36 divided by 2, and then you will get the x 3.8. So you all already have the points. Now we can plot into the graph. So as you can see, this is the graph that you will get. So first, if you don't know how to do the graph, first thing first, you have to do the vertex first. You plot the vertex, which is the red line, and then you plot it the y-intercept, which the area is y-intercept, and then you just plot the x-intercept. So you will get the downwards graph. Okay. Okay, so now we're going to I'm going to give the another presenter for the case study one.
Okay, for the case study one, the question is company A sell a product where the unit price is Px equals to 100 minus 2x dollar. The cost function is Cx equals to 50x plus 200, where X represents the number of units sold. So based on the provided equation, we can find the revenue function, profit function, break-even analysis, and maximum revenue. So for the revenue function, we can use Rx equals to XPX. So we put the PX from the previous slide, 100 minus 2X into the equation. So it will be Rx equals to X times in the bracket 100 minus 2X. So we expand the bracket, it will become Rx equal to 100X minus 2X squared. Next for the profit function. So profit function, as we know, the formula is Px equals to Rx minus Cx. So it is revenue minus with cost. So the revenue we got from the previous slide and the cost from the initial one will become, and then we put the function into the formula. It will become Px equals to 100x minus 2x squared minus 50x plus 200. The cost function, we need to put bracket in front because there is a minus in front, the C, the cost function. Next, we expand the bracket. It will become 100x minus 2x squared minus 50x minus 200. So we minus 100x minus 50x. It will become 50x minus 2x squared minus 200. So this is the profit function. So next, break-even analysis. So break-even analysis, there's two formula, which is Px equals to 0 and Rx equals to Cx. So because we got the profit function previously, so we are going to use the profit function equals to 0. So it become 50x minus 2x squared minus 200 equals to 0. And because of this x squared, we are going to use the quadratic formula. It will become x equals to negative b plus minus square root b squared minus 4ac over 2a. So we put uh, the b, which is 50, a, which is negative 2, and c, which is negative 200. And because there's a plus minus here, we are going to have two answers. For the first answer, x1, it will become negative 50 plus with square root 900 because we have already solved this by using the calculator, over with negative 4. Then the answer will become 20 over 4 equals to 5. So for x2, it will become negative 50 minus square root 900 over negative 4. So finally the answer is x2. So these two answers are positive. So this break-even analysis will say that if the x is equal to 5 and 20, the company will achieve the break-even. So next one, the maximum revenue. So for the maximum revenue, we are going to use this formula x equals to negative b over a. Will become the b based on the revenue function. B is 100 and a is negative 2. So you put it inside this formula. X equals to negative 100 over 2 times negative 2. So our x will become x equal to 25. Then we substitute x equal to 25 into the revenue function, and by using the calculator we got the answer. So the final answer is R25 is equal to $1,250. So based on all the function, the revenue function, the cost function, and profit function that we get, we can plot this graph. So the green one is the profit function, and the revenue function is the blue one. The red linear one is the cost function. And we can see the purple one, this is the break-even a number. So I will pass for the next presenter.
Okay, now this is the case study 2. So this is the scenario. Is a startup company want to launch a new eco-friendly water bottle. The company incurs a fixed cost of $10,000 for production equipment, marketing, and other initial expenses. So the variable cost per unit, that is for material and labor, is $5 per bottle. They plan to sell each bottle at a price of $15. So the objective is to determine the break-even point, the number of bottles they need to sell to cover all the costs and start generating a profit. So step 1 to do is the defining the equation. So first we have to bring out the total. First is total cost. Total cost is the sum of fixed and variable costs per unit, and then the variable cost must times with the unit, the number of unit that is called x. So you will get cx equal to 10,000 plus 5x. And second, we have to find the total revenue. Total revenue is equals to selling price per unit and times x. So already given in the question, you can see it is rx equal to 15x. And then lastly, you will get the break even point. So the formula to use to find the break even point is rx equal to cs. So you guys just substitute the equation that you already have. So Rx equal to 15x, Cs is 10,000 plus 5x. So you guys just rearrange it. So 5x will be minus 5x equal to 10,000, and then you get 10x equal to 10,000, and then you just take the 10, make sure 10,000 divided by the 10 because you guys rearrange it. So you guys will get the x equal to 1,000. So the break-even point occurs when 1,000 bottles are sold. Okay, so step 2, just in case. Okay, this is for verifying the solution to know is it correct or not. So for this one, we already have the x equal to 1,000, so you can just substitute the s into two of the equation, is total cost equation and total revenue. So as you can see, the total cost and the total revenue are the same. You will get 15,000. So since the total cost and the total revenue are the same, the solution is verified. So it's good. And now you can do the graph plotting. So as you can see, the graph plotting, the blue line represent the total cost. The green line is represent the total revenue, and the red point is at the 1,000 and also 15,000. 15,000 is from the we calculate the number. Okay, so this is the graph that you going to have. Okay, so for conclusion for our presentation, in this report, we learn how to use specific equation and formulas to get the answer for the question given. So in demand and supply function, it shows that price and quantity plays a big role in ensuring the profitability one can get. The market equilibrium can be achieved by using the Qx equal to Qd formula. The cost and revenue function teaches us how to get the profit by using the formula Ps equal to Rx minus Cx. So the formula Rx equal to XPX can be used to get the revenue function, and the cost function is the total of the fixed cost and variable cost. The break-even analysis is the analysis of the relationship between cost, revenue, and profit. So the main purpose of the analysis is to determine the point at which the total revenue is equal to total cost or the profit is equal to 0. So Rs equal to Cs and Ps equal to 0. So the optimization of profit, revenue, cost is the process of finding the minimum and maximum value. We can use the you can use the x equal to negative b divided by 2a to find the symmetry line. Then we can use the x to find the maximum or the minimum based on the equation given. So thank you for listening.